The objective of this lesson is to simplify nth roots that have variables involved. This will be an introduction to it. We're going to look at the steps involved for it and a few examples. So first of all, our first step for doing these problems is to separate using two rules. Now this is primarily the two rules that we'll use. The first rule is if you've got the nth root of a times b, that's going to be the same as if you separate it and make it the nth root of a times the nth root of b. So that's the first one to use. The second one, this is when we have multiplication. If you have division, which means a fraction, so if you have the nth root of a over b, you can separate that into the nth root of a over the nth root of b. Now this will just help us when we're simplifying these to get them into a form that's easier to work with. Next, what you want to do is simplify using fractional or rational exponents. And then the next step, which we're going to use pretty soon, but it's going to be something I'll show you in an example. So what you want to do is you want to use absolute value when necessary. Now, when we use absolute value is when we involve and when we have our index being an even index. Now let me show you what I mean by that. Let's first of all use absolute value when simplifying, and you've got, in this case, an even index. And I'm going to put down here when necessary. And I'm going to tell you what those kind of the guidelines or the rules are for that. There'll be some specific steps or guidelines for when we want to use that. All right, so let's go ahead and do some examples here. So the first one, what I want to do is take a problem like this. If we've got the square root, so I'll start with the square root of 64, x to the 12th, y to the 20th power. Now for this one, notice again that that's implied to be a 2. When the index is not listed, the implication is that, the assumption is that that's a 2. So I'm going to separate it now. I'm going to make this the square root of 64, which we know, the square root of x to the 12th, and then the square root of y to the 20th power. Now we know the square root of 64 is 8, so we start there. Now these we're going to use the rational exponents. I'm going to make this 12 over 2 because my index is 2. I make that the denominator of the rational exponent. This will be 20 over 2. Now I can simplify that. This is just 8x to the 6th, y to the 10th for that answer. Notice that is nice and clean. You go ahead and separate it out and then simplify each of the parts. Now the next one, what I'm going to do is use it with an odd. So we're going to do the 7th root of 128. Let's use a to the 14th and b to the 35th. All right, now let's separate them. So 7th root of 128, a to the 7th root of a to the 14th power, and the 7th root of b to the 35th power. Now, you might not know the 7th root of 128, so you might have to do this, 128 to the 1/7 power. This will be a to the 14 over 7, the denominator is the index, and b to the 35 over 7th power. Now I'm going to find this 128 to the 1/7 power. So I'll go to this and say, let's clear this off, 128 raised to the 1 divided by 7th power, and that gives me a 2. Now, if it doesn't turn out nicely, you might have to, we'll talk about those later on in a later lesson, but when you get that fractional exponent, you can use your calculator to help you out. And then you just have a to the 2nd and then b to the 5th simplified. Those are nice, neat, and clean. Now those are ones that turn out nice and neat and clean. What happens though, now I've got to consider with an odd index, I don't worry about absolute value at all, but if I have an even index and my result down here turns out to be an odd number, I've got to be careful because what comes out of a root is going to be the positive value. That's the function that we have, is that the root produces a positive. If this is as an odd exponent on it, we've got to ensure that it's positive by putting absolute value on it. So let's come up with a couple rules down here that will help guide us. If you have an even index on the problem, okay, so like this one, even index, but there's an odd result in it, and I'll show you an example of that coming up, you need to put an absolute value on that part of the problem. Now, if you have an even index with an even result, which I worked out this first one, even index, and the results of both of the exponents and the variables was even, then these can't ever be negative already. You don't need absolute value. X to the 6th can't ever be a negative number. So you don't need absolute value there. So when that happens, even index, even result, you don't need to worry about any absolute value. So no absolute value. And then lastly, if you have an odd index, because odd indexes an indice can produce a negative answer, you don't have to worry about any absolute value ever. It doesn't matter what the result is, positive or even or odd, the result could be either. You don't have to use absolute value for that. So let's do an example that involves this. Let's do the 4th root of 625. Let's do x to the 20th, and then let's do y to the 16th. All right, now the number we don't have to worry about. You take and split it up, the 4th root of 625 times the 4th root of x to the 20th times the 4th root of y to the 16th. This, if you do the 4th root, do 625 to the 1/4 power, you will get that's equal to 5. This one will have x to the 20 over 4 power, and this is y to the 16 over 4 power. Now if we simplify those two, this can be x to the 5th, and this will be y to the 4th. This y to the 4th can never be negative. You put something in an even power, it's never negative. So that doesn't need an absolute value, but this one does. In the original, notice that I could put a negative number to a 20th and it would turn into a positive. I can take the square root of it and I'd end up with a positive number. But the problem is this is saying as a result, if you put that negative to a 5th power, it will end up as a negative. So you have to put absolute value on it as a result. So whichever one of these, if you've got an even index and the exponent on one of the variables comes out as an odd number, put an absolute value on it as your final result, and there you get your answer. So our steps for doing this are to separate, then to use those fractional exponents. Go ahead and help you to solve and simplify using those. Then remember that once you simplify, you can use these absolute value rules to determine whether absolute value is involved. If it's odd, it never has an absolute value, but if it's even, this will tell you whether to include an absolute value or not include an absolute value on your answer.